Good morning. I'm here to talk on engineering mechanics. I'll be doing a full course on engineering mechanics. In today's lecture, we'll have a brief introduction to what is engineering mechanics and also on vector algebra, which becomes a base for studying engineering mechanics, and a few problems, vector algebra, applying to real life situations. Engineering mechanics is a branch of engineering that applies the principles of mechanics to engineering design. It is built up on the physics which you have acquired in your class 11 and 12. Mechanics is a branch of physics which considers the force acting on a body or on fluids which are in rest or in motion. Statics and dynamics together constitute engineering mechanics. Statics, we deal with systems at rest, while in dynamics we will talk about systems in motion due to the force. The primary goal of this course is to introduce engineering applications of mechanics, by which the student should be able to solve simple and complex problems in statics and dynamics applied to real life situations. You'll also see this course is followed by an applied course on engineering materials, dynamics of mechanisms, vibration and machine design. So, engineering mechanics is a fundamental course which forms a base for the subsequent courses. The course will be of useful for other than engineering students, mechanical engineering students. It will be useful for aerospace, architectural engineering, civil engineering and other engineering programs as well. With this brief introduction, we will move on to the fundamentals of vectors. Knowledge in vector becomes a prerequisite to study statics and dynamics. When I say vectors, its counterpart is going to be scalar. Scalar are those quantities which has only magnitude, while vectors possess both magnitude and direction. Examples for vectors are displacement, velocity, acceleration, force, etc. I'm sure the students should have a good knowledge on what is scalars and vectors. We'll quickly run through a comparison between a scalar and vector. I've put it in a small tabulated form so that it becomes easy for you to grasp it. Scalar quantities are always positive, while in vectors it can be a positive or negative depending upon the frame of reference. To give you an example, distance is a scalar. We say 10 meters or 20 meters, whatever it is, but displacement is a vector. It could be minus 10 meter or 10 meter depending upon in which direction you move from the reference frame. Scalar addition and subtraction is simple algebraic. For example, if I have 5 plus 3, 5 kg and 3 kg would be 8 kg. It does not matter what you add, whether you add mass of wood and mass of a steel, the total weight is going to be 8 kg. But here it depends upon the orientation. It could vary from 5 plus 3. If both the forces are acting on the same direction, it is going to be 8, or it could be 5 minus 3, which is going to be 2 when they are act in opposite direction. Similarly is the multiplication. 5 into 3 is going to be 15. Here 5 into 3 can either be a 0 or 15 or anything else also, depends upon whether you are performing a scalar product or a vector product. And both scalar and vector product has their own physical significance, which we will talk in detail when we talk about their applications. Having seen this, we will go into how to represent a vector. A vector is usually represented in its rectangular components, which is mutually perpendicular to two reference frames. Let's say if I have a vector v, the vector v is resolved along the x and y axis, which is going to give me a Vx and a Vy. Vx is going to be V cos theta and Vy. Vx and Vy are called as the rectangular components of the vector. A vector can also, there is another vector called unit vector, which is going to be a vector in the direction of the z vector of magnitude unity. This is representing a vector in 2 dimensions. When it comes to 3 dimensions, the vector has to be represented in the x, y and the z axis, along the x, y and z axis. that v of p vector is going to be vxi plus vyj plus vzk, where vx, vy and vz are the components along x, y and if theta x, theta y and theta z are the angles made by the vector with x, y and z axis. Cos of theta x, cos of theta y and cos of theta z are called as the direction cosines and are represented as L, M, and L is going to be Vx by mod V, Vy by mod V is M and Vz by mod V is N. The magnitude of the vector is given by square root of Vx square plus Vy square plus Vz square, and L square plus M square plus N square should also be equal to 1. So this talks about the representation of the vectors in general. We'll move on to addition of two vectors. Before that, we need to talk on the other terminologies used in vectors. When a set of vectors lie on a single plane, then we say that the vectors are coplanar. If the same vectors act along a single line, then it is said to be collinear. So collinear, if collinearity is maintained, then the vectors are also coplanar. What is a concurrent vector? Non-collinear vectors when they pass through a particular point, then the system is said to be concurrent vectors. Addition of vectors. Vector addition is in accordance to the parallelogram law, which says that the diagonal of the parallelogram is the sum of two vectors. Let's consider P and Q are the two vectors. We construct a parallelogram by joining the two ends and drawing parallel lines parallel to P and Q, and R is the resultant vector. The magnitude of the R vector is given by square root of P square plus Q square plus 2PQ cos theta, and the direction of R vector with reference to one of the vectors is given by psi is tan inverse of Q sin theta by P plus Q cos theta. Vector addition is commutative, which means that A plus B is going to be B plus A, or P plus Q is going to be Q plus P, which is also equal to the R vector. I am here to give some useful tips which will benefit the students while solving problems, especially when they appear for competitive exams, when they work with restricted time. The first is, resultant of two vectors is always going to be in a range which is going to be a maximum of between A plus B and A minus B, depending upon the orientation of vectors, which means that let us consider A to be 5 units and B to be 3 units. We will use the same example. A plus B can be 8 units if theta is 0, and A plus B would be 2 units if theta is 180 degree. When two equal concurrent forces act at a point, the resultant vector always is an angle bisector. For example, let us take F vector, and this is another F vector making an angle 90 degree. The resultant is going to be such that it makes an angle of 45 degrees. You can generalize it. If theta is the angle, the resultant will be 45. If it is 60, it is 30, 120, 60 and so on. So the resultant is always an angle bisector. When the system is subjected to a concurrent force, it is said to be in equilibrium if the vectors form a closed polygon. For example, let us say I have F1, F2, F3. If I can construct a polygon which goes like this, F1, F2, F3, then the system is said to be in equilibrium. That is, sum of all the vectors is 0. With this brief introduction, we will also talk about vector products. Vector product is done by, there are two types of vector products. One is called as a dot product, the other one is called as a cross product. We will first talk about dot product. Dot product of two vectors A and B is denoted as A dot B. We write it as A dot B, and it is defined as A dot B is going to be mod A mod B cos theta, and this is a scalar quantity. Some of the rules which the dot product follows is A dot B is equal to B dot A. It is commutative law is valid, and that is this is going to be a scalar, so it does not matter in which order it is multiplied. The second is A dot B plus C is A dot B plus A dot C. It is distributive law which is also followed. It obeys a scalar multiplication. When the vector is denoted in terms of its components I, j, k, it is I dot I is equal to I dot j is equal to I dot k, which is an unity, because angle between the two vectors is 0 and cos 0 is 1. While a product of I dot j, j dot k and k dot I is 0 because theta here is 90 degree. Theta here is 0. A quick multiplication of two vectors given A and B. A vector is denoted as AXI plus AYJ plus AZK. Similarly, the B vector is BXI plus BYJ plus BZK. Then A dot B is equal to B dot A, which will give us AXBX plus AYBY plus AZBZ. Similarly, A dot A would be AX square, AY square and AZ square. This is an important condition which we use for solving problems. If A dot B is equal to 0 and A and B are not equal to 0, then A and B are perpendicular. This is a very important rule which we use for determining the orientation of two vectors. The next one we will talk about is cross product. The cross product is denoted as A cross B. C is equal to A cross B. Here it's called as a cross product or a vector product because the resultant is a vector, and the vector is going to be this n vector, which gives a direction. The n vector indicates the direction of A cross B. If the vectors are parallel, sin theta is 0, so A cross B is 0. Similar to your dot product, here also we will talk about some of the rules which are applied. The first one is A cross B is not equal to B cross A, so commutative law fails. The distributive law A cross B plus C is going to be A cross B plus B cross C, it obeys. I can multiply it with a scalar. I cross I is equal to J cross J is equal to K cross K is equal to 0 because theta is 0 and sin 0 is 0. While I cross J is equal to K, J cross K is equal to I and K cross I is equal to J. This can be, for a quick reference, the students can use this I, J, K. I cross J would give me a K, a K cross J cross K would give me a I, and so on. So this is positive, while I, J, K, if they go on the opposite direction, it is going to be negative. This they can use it as a quick reference to work on it. The physical significance of a cross product is that it gives the area of the parallelogram. So cross product means area vector. From this you would have understood area is primarily a vector, not a scalar. It's a cross product of the length and the breadth. If the A vector is denoted as AXI plus AYJ AZK and B is denoted as BXI, BYJ and BZK, A cross B is given by the determinant as shown below. The direction of, I haven't mentioned it here, the direction of the n vector is based on, I will write it here, is given by with this brief information, we will try to work on certain problems.